Hello guys, welcome back to this series on data analytics with R. So in this video we are going to see functions on vectors, and we'll also see a topic called vectorization. So we'll see these functions: sum, length, min, max, median, mean. Then we'll see how we can calculate standard deviation using vectorization as well as the built-in function. We'll see a special function called factor. We'll see how it can be used as histogram, and operations on vectors which have unequal lengths. So like this is a 2 element length vector, this is a 3 element. What happens when we add both of them, and so on. And finally we'll see what is sort, order and rank. So that's for this video. Let's get started. Okay, so let's say I have a vector 2 5 7 8 10. X is equal to 2 5 7 8 10. And so you remember the C function, the combine function by which we can make a vector. Just let's see what the sum of x, length of x, min value, max value, median, mean. Okay, press shift enter and there you go. So the sum is 32, the length is 5, minimum value is 2, maximum, this is the median, and this is the mean. Okay, now it's very difficult to actually understand what these values are. So what you can do is you can also print it, and then there's a command paste. By this what you can do is you can insert strings as well as uh, numbers. So like the sum of x is, and then you say sum of x. So I'll give you this nice thing. The sum of x is 32. So similarly you can do this for every case. So here you can see this makes it more readable, right? So yeah, you can use the paste function to mix strings as well as variables or numbers that you have. Okay, so this is quite handy. Okay, now let us see how we can get the standard deviation using vectorization. So what I mean by vectorization is the following. So say we do x minus mean of x. Okay, so if you actually see x, okay, let me just print everything here. So x and mean of x. So you see x is a vector, it is a 5 element vector, 2 5 7 8 10. Mean of x is just one number, 6.4, just one number. So how do you actually subtract one number from the whole vector? So that is by doing element wise subtraction. So 2 minus 6.4 will give you minus 4.4, 5 minus 6.4 will give you minus 1.4, and so on. So this is like an element by element wise subtraction. Okay, so whenever you have a vector minus a scalar, the scalar will actually get repeated. So you can assume this as a vector having all 6.4 values, and then both get subtracted. Okay, so this is a thing that is known as vectorization. So you are actually not allowed to do this in some compiler based languages like C++ and so on. You will have to use a for loop over there, but here in R you can just do x minus mean of x and it takes care of everything. Okay, also in R, because this is an interpreted language, this using vectorization, that is using something like this, is faster as compared to using for loops. So you can also write for loops in R, but then those will be slower as compared to the vectorization, because this code is built in a compiler type language like C++ in R. Okay, so if you don't understand any of these things, no problem. The only thing that I want to say is that use vectorization as much as you can, because that will make your code faster. Okay, so now let us see how can we create this formula over here. So it's simple. So you have done x minus mean. So now you just need to put a square. So here is the square. Then what you need to do, then you need a summation. So the summation is nothing but our sum operator. It will sum all the elements. Okay. Then you need to divide it by the length of x. So n is nothing but the total number of elements, that is the length of x, minus 1. Okay, and this whole thing will go in square root. Okay, so this is the standard deviation that I get by vectorization. There is also a built-in function st, so you can also use that. So you see you can get the same. So I just showed you vectorization because it is faster as compared to for loops. So if you don't know what is a for loop, just hold your horses. I'll have a video on that as well. Okay, so yeah, so this is quite handy using vectorization. Then there is repeated numbers. So for that you can use the command rep and 1 comma say 10. So what will happen is it will repeat 1 10 times. So here you can see 1 is repeated 10 times. Okay, you can also do something else, like say c1 comma 2. So here 1 comma 2 is repeated 10 times, or you could also tell how many times you want to repeat it. So say 1 I want to repeat 5 times and 2 I want to repeat 10 times. So it will repeat 1 5 times and it will repeat 2 10 times. So this is just to repeat the numbers. So you get a array with repeated elements with this function. Okay, so I mean I am trying to give you the basis of basics of R. So that is familiarizing you with the simple functions. There are a lot of functions. You can just Google it, type the command, and you can get whatever you want, right? Okay, this is an interesting function, factor. So let us first define a pane vector. So this is a pane vector and it has 0 3 2 2 2. Okay, these are the elements of the pane vector. I'll just show you what is pane, and then what we can do is say define a f pane. Also one more important thing, you can also use this arrow instead of equal to. I mean both the things are the same in R. Okay, so they have also implemented this. And if you press alt minus in your keyboard, alt and minus, you automatically get this sign. But I don't know, equal to is more logical for me, so I always use equal to. Okay, so f pane is equal to factor pane in levels 0 to 3. So what will happen is f pane will actually give different levels to this according to this level. So it says 0 to 3, so 0 will become a level, 1 will become one level, 2 the other level, and 3 is the other. So 0, 1, 2, 3. And now when you have these levels, you can actually name them as well. So you can say let levels of f pane be equal to say none, mild, medium, and severe. And then when you print f pane, you'll get this. So f pane, so this was 0, that means there is none. So you see these levels are matched with these words. So 0 becomes none, 1 becomes mild, 2 becomes medium, and 3 becomes severe. So 0 is none, 3 becomes severe, 2 is medium, and there is no mild because there is no 1. Okay, you get that. So I mean you can use factor to actually put levels in your vector. So if it is variable like this that has levels, so none, severe, medium, and so on, this can be used in fuzzy logic if you know about fuzzy logic. So these things are popular then. Another thing is you can also use factor as histogram. So say I have a x variable where it is say these tt f f t t t, and I'm just plotting factor of x. So if you see, it'll give me the histogram. So capital T how many times? So there is 3 times capital 3, capital T is 3 times, F is only 1 time, and small t is 1 time. So you can see this is case sensitive. So capital T is different from small t. And if I have not introduced this, so this is the plot function. You can plot uh, graph over here. Okay, you can also plot something like a sine wave. So say sine, I can use the colon notation here. Say I go from 0 to uh, 2 into pi. Oh, there are very small these things. So let me just put sequence over here. Yeah, there you go. So you can plot a beautiful sine wave like this. Okay, what else? Okay, now we'll see operation on vectors with uneven lengths. So here you can see x has 2 elements, 1, 2. Y has 3 elements, 1, 2, 3. Now if you see x plus y output, you see 2, 4, 4. So 1, 2, this was just 2 elements, this was 3 elements. How did we get 2, 4, 4? So the initial is same. I mean 1 plus 1 gives you 2, 2 plus 2 gives you 4. How did you get this 4? So what actually R does is it recycles the vector. So what it does is, so the smaller vector will repeat itself till it matches the length of the bigger vector. So here 1, 2 is a smaller vector. It will add an extra 1, that is repeat it like this. So if there is a bigger number, there will be 1, 2, 1, 2, 1, 2, 1, 2, and so on. So this will happen till it matches the length of the second number. So the second number is 1, 2, 3, or the second vector is 1, 2, 3, and now it'll add. So 1 plus 3 is 4. So you get 2, 4, 4. It'll also give you a warning message that longer object length is not a multiple of shorter object length, to just make you sure that things don't go the way that you don't want to go. Okay, so this is what happens with R. So please make sure that you want something like this to happen, because normally in programming it happens when you're not aware of the lengths and you add both the vectors. For different programming language like Python or MATLAB, it will give you an error that the lengths are not equal. But R is a little one step ahead, and it does something like this. Okay, so make sure that you know what you're doing basically. Okay, now let us go to what happens if you add three numbers together. So say x is 1 comma 2, y is 1 2 3, and z is 1 2 3 4 5. Okay, so what we would actually see, if suppose we are adding x plus y plus z, so we would assume that what will happen is the smaller element the smaller element vector x would repeat till it matches the length of the bigger element, right? So in this case it should be 1 2 1 2 1 1 2 1 2 1 till it matches the element z, I mean the length of the element z, that is 5. And then 4 will become 1 2 3 1 2, it matches this, and then 1 2 3 4 5, and then add all of these. But this is actually wrong. R does not uh, add like this for three elements. For three elements, what it'll do is it'll first see the first two elements, only the first two elements, and the first two elements will be first added. So that is 1 2 1, and then 1 2 3. So as we did in the previous sum here. So you get the output as 244, and then 244 will be repeated. So you have got x plus y. Now this thing x plus y will be repeated till we match the length of z. Okay, so 244 will be repeated till we match 2 1 2 3 4 5 over here, and then now you add these two. So 2 plus 1 is 3, 4 plus 2 is 6, 4 plus 3 is 7, 2 plus 4 is 6, 4 plus 5 9. And this is the x plus y plus z output. Okay, so this is very important that so let us just see first. Okay, let me comment this. Just let me remove it for now. Okay, so you see 36769, 36769. So this is the correct method. Okay, if you think this will happen, this is the wrong method. Okay, this will give you a different answer. You can see 1 plus 2 is 3, 3 plus 5 is 8, but you get 9. Okay, so this is the wrong method. Okay, I don't know where this will be useful, but it is just to make you familiar that if you have unequal length vectors, you could have some problem. I mean, if you don't know what is happening, normally we don't do this in some mathematical or statistical operations. So just to make sure that you know what you're doing. Okay. Yes, so let us come to our final thing, that is sort, order and rank. So let's say I have a vector x that is 5 6 4. Okay, so what sort will do basically is sort will sort the elements of x. So 4 6 5 4 5 6. Okay, so 4 5 6 will sort these elements. What order of x will do is order of x will give you the index of the sorted elements of x. So that is 4 is at the index 3. So 4 is at the third index, so 3 will come over here. 5 is at the first index, so 1 will come over here. And then 6 is at the second index, so second. So sort of x sorts the elements for you. Order of x will actually show the indexes for the sorted elements, and rank will actually tell you which one is how big. So 4 over here is the smallest, hence it will give the rank 1. 6 is the largest, so it will give the rank 3, and 5 is the middle element, so it will give you the rank 2. So make sure so order and sort, they actually sort the elements. Rank does not sort, it just ranks all the elements and tells you which is the smaller and which is the largest by these numbers. Okay, this photo will make things more clear. So we have this vector 5 6 4, so this is 5 6 4, and you have position 1 2 3. So this is at the first position, second position, third position. Now if you sort the use sort over here, what will happen is the smallest number will come at the first position, the largest will come at the last position, and this will in the middle. This will be in the middle. So now this is what sort will do, sorted value or something. So 4 5 6 is the sorted value. This is the position 1 2 3. And what will rank do is rank will tell you where did what go. So 4 had the smallest value. I mean, this was the smallest, so it will get a rank of 1. So whatever is the sorted position will come over here. 6 has the rank of 3 because it is the largest element, and 5 will have a rank of 2 because it is in the middle. So basically it just ranks the elements by how big they are or how small they are. Okay, and order will just give you the position of the sorted thing. Okay, I hope this is clear, and that's all for this video. Thank you so much for watching. Thank you.